So this is going to be an answer to a question from 9.2. So if you have an inequality like this, where it's a fraction with x's on the numerator and the denominator, the first thing that you want to do is you want to make sure that you don't divide by 0. So we're going to take the denominator and set it equal to 0 to find out what value of x would make the denominator equal to 0. So here, x minus 2, when that is equal to 0, add 2 to both sides and x equals 2. So when x equals 2, that makes the denominator 0, which is illegal. We can't divide by 0. And so then we know that that's going to be one of our critical values, and that will use a parenthesis for this interval. And then we are going to multiply x minus 2 to both sides of this inequality. So x minus 2 to both sides. X minus 2, which cancels this, and 0 times x minus 2 is just 0. So this gives us negative x plus 5 is greater than 0. So now we have a normal, pretty simple inequality. So how we solve this one is we set this side equal to 0. So negative x plus 5, if we set that equal to 0, that makes x, subtract 5 on both sides, divide by a negative 1, which makes x equal to 5. So this is our second critical value. So now what we will do is create a number line on which these critical values would lie. And we're going to test the areas in which they would lie. So here's 2 and 5. And we know that at x equals 2, this inequality cannot exist. And when x equals 5, this side of the inequality is equal to 0, so this does not work either. But now we have to test on each side, or each area of this number line. So let's go ahead and test that. So this is what the chart is kind of looking like. So make a chart of our test areas, and we'll have some test value that we'll use, and I'll explain that. And then we'll have our test equation. Here. So we're going to test this area here first. So before the 2, which is from negative infinity all the way to 2, but not including 2, because we already know that at 2, this inequality cannot work. So we're going to test this area right here. And so you have to pick a number that's between negative infinity and 2. So I'm going to pick 0. So our test value will be 0. And this goes right here, the area that we're testing. And so when our test value is 0, when x is 0, we'll plug that into this equation, and we'll see if it works. So at 0, negative x is negative 0 plus 5, which is 5. And if we plug x equals 0 into the bottom, that's 0 minus 2, which is negative 2. So negative 5 halves, is that greater than 0? No. So this area does not work on the graph. Now we test the area between 2 and 5. So let's test the area between 2 and 5. So let's pick the number 4. When we pick the number 4, we plug this in. That gives us 1 over 2. So 1 over 2 is greater than 0. So this works, and we will use this in our answer. Now we have one more area to go. So we've done this area and this didn't work. We've done this area and this did work. Now we just have to test the area from 5 to positive infinity. So pick any number between 5 and positive infinity. I'm going to pick 10. 10 is the easy number. So this becomes a negative 5 over 8. Is that greater than 0? No, it is not. So this isn't in our answer. Therefore, our answer is only at this interval between 2 and 5. There we go.